Hello and welcome to this Chi-Prime video where we solve a problem to prepare for the GMAT. As usual, I'll give you a second to pause the video if you'd like to solve the problem yourself, and then we shall proceed to solve the problem together. Alright, so let's begin. Here we're given that a circle C of radius r is such that its center lies within a square S of side 2r. So let's first draw the square. Pardon my drawing skills here. Let's imagine this is a square of side 2r. And we're given that a circle of radius r is such that its center lies within this. So the center can lie anywhere within this. So let's call this the center of the circle C. Okay? Now, we're asked to find the smallest and largest probabilities of picking a point in S so that it also lies in C. It should be obvious to, from reading the problem, that the largest probability of picking a point that lies between both lies on both S and C would occur when the overlap between S and C is the maximum, right? So in other words, where C lies completely within S is when you have the maximum chance of picking a point within the square so that it also lies within the circle, right? So this is the maximum. So let's call this P max. And the minimum probability will be such that the center of the circle only has minimum overlap with the square. So in this case, the side of the square is 2r, right? The radius of the circle is r. So this is r, this is r, this is r, this is r, and you only have a quarter of the circle. So P min occurs in a situation where you have a quarter of C lying within S, right? Quarter of the circle C lies within S. Okay, so let's compute the values in each case. So this is the ratio of the areas of the circle to the square. So the circle has radius r, so the area of the circle is pi r squared, and the area of the squared of side 2r, again the radius of the circle is r, this touches here, this touches here. All right, so the area of the square is 4r squared, right? Which is equal to 2r the whole squared, right? So that's the area, that is the probability, the maximum probability that any random point that you pick within the square also lies within the circle. And the minimum value of the probability is given by pi r squared divided by 4. That's the area of the quarter circle divided by the area of the full square. So that's 2r the whole squared, which is pi r squared by 16 r squared, which is pi by 16, and the other case it is pi by 4. All right, so we need to compute the values of pi by 4 and pi by 16. Let's try this first. Let's assume pi is 3.14. We know it's a transcendental number that has an infinite expansion, but for purposes of this calculation. So if you carry out this calculation, then you see that this comes out to 0.785. Not that hard to do, really. For pi by 16, we just realized that this is pi by 4 divided by 4. So we just take this number here, then divide that by 4, and we get something like 0.1963. All right, so the minimum and maximum values of the probability we're looking for are 0.1963 and 0.785. And that we see is option D, 0.1963, 0.7854. So there you have it. That's how you solve this problem. Thank you for watching.